Hi everyone. So in this video session, I'm just going to solve one question from electronic devices. So what I want to show here is whatever concept we discuss in the classroom, okay, that is not enough to solve the problem. Remember that, okay. In electronic devices, you have to play with the numbers, okay, and also you have to handle the online calculator because the numbers will be quite different, okay. Understand? So I'm just going to solve this question, okay? And this question was one of the good question, okay, where many students make mistake in calculation, despite you know concept, right? So in electronic devices, or you can say in semiconductor physics, knowing the formula, knowing the concept is not enough. If that is numerical answer type question, okay? If it is not numerical answer type question, then knowing the concept is enough. But if it is numerical answer type question, so knowing the formula, knowing the all the equations that you know, right? Knowing the concept, knowing how to handle those numbers that you will get after plugging the information given in the question, and then adjusting to the required answer, right? Whatever answer they will be asking the question, right? So let's have a look to get 2023 electronics and communication paper question. So this question was asked in electronics and communication in 2023 for 2 mark. ठीक है, तो बहुत सारे लोग इसमें मिस्टेक करते हैं, है ना. इनफैक्ट टॉपर्स आल्सो मेक्स मिस्टेक. ऐसा कुछ नहीं है कि टॉपर जो है तो उसको बहुत ही ज़्यादा आता है, वो भी इस क्वेश्चन में मिस्टेक कर ही देता है, राइट. सो हु इज़ गोइंग टू हेल्प यू to come out from this problem? So the teacher only, kind of experienced educator, is going to help you, to get out of this problem. So I'm just going to solve this question. You see how simply we will solve, and I will also show you the calculation demonstration using online calculator, right? So in a semiconductor device, the Fermi energy level is 0.35 electron volt above the valence band energy. So they have given something here, like they have said that, that how Dheeraj sir solved the problem. Whenever he reads the question, he always try to understand using energy band diagram. Okay. In fact, one of the Nobel laureate also says that if you don't know how to draw the energy band diagram for the semiconductor devices, you don't know anything in devices. And if you know how to draw the energy band diagram of any semiconductor devices, but you don't know how to explain that, then you don't know still anything in electronic devices. So remember that understanding the energy band diagram qualitatively, like if you want to understand devices qualitatively as well as quantitatively, you need to know the energy band diagram, right? So first line says that the Fermi energy level is 0.35 electron volt above the valence band energy. So you can say this is the valence band energy, this is the conduction band energy, okay? Simplified energy band diagram. And above this guy, above the valence band energy, there is a Fermi level, you can say EF. And this Fermi level is nothing but 0.35 electron volt. They have given the question. Now they have also mentioned that the effective density of a state in the valence band. Okay, so E DOS is also given. Effective density of a state at T equal to 300 K. Remember, this temperature is very important. Okay, most of the time, when you go through semiconductor physics theory, people will talk about 300 K only, right? But if temperature raises, if temperature increases, then you have to be little careful how your effective density of state in the valence band, that is called NV. So in this question, NV is given. So NV is nothing but 1 into 10 raised to power 19, right? Okay, per centimeter cube at 300 K they have mentioned. Okay. What you have to find out here is you have to find out the thermal equilibrium hole concentration in silicon at 400 K. See, they are not asking you to compute hole concentration, thermal equilibrium hole concentration at 300 K, right? You can't use this NV directly. Okay. You can't put that. Many students do it. Okay. Many students, do it. Okay. They always, what they do is they directly put it. But also they don't know how NV is related with temperature, right? Because NV formula, if you look at NV formula, it looks 1 inch long formula, but at least you should know the temperature dependence, right? How NV varies with temperature, right? And how your KT is gonna vary with temperature, because KT is also given at 300 K. But what is your goal here? Is your goal is to find out thermal equilibrium hole concentration at 400K. Remember this, at 400K, right? So our goal is what, guys? Let me write the goal here, right? See, KT is also given here. You can mention KT, but needless to write in the gate exam. Directly understand, because screen will be in front of you. So आपको ये given when लिखना नहीं है, टाइम वेस्ट क्यों करोगे, राइट? मैं बताता हूँ कहाँ से आपको लिखना है. So KT is given as what? KT is given as 300, 0.026 electron volt, okay, at 300K. Now in the exam, from where you have to start writing, let me show. So what you have to write here is, you have to write P naught at 400K. ठीक है, ये आपको लिखना जरूरी है. ठीक है. Now you write this, and then you can write NV, okay, NV at 300K, okay, times that temperature dependence. NB is gonna vary, right? At 400K you have to find, right? So, or else what you can do here is, let me write one more thing, okay, here only. I can show that NB should be computed at 400K. Let me write first that. Okay. So NV at 400K. Okay. E raised to power minus EG. Sorry, not EG. It will be nothing but your gap. Okay. What is that gap? That gap they are talking about is, EF minus EV by KT. Okay, this KT has to be evaluated at 400K only, right? You see this. How to write this formula? You know that this is the conduction band energy, edge of the conduction band, edge of the valence band, and the Fermi level is here near the valence band. Okay, so this gap is going to decide the concentration of hole, right? If this Fermi level is close to conduction band, so EC minus EF is going to decide the, so remember that all those approximations are valid also. You have to always take into account that the approximation is valid here. That is EC minus, EF minus KV, sorry, EF minus EV. That should be less than minus 3KT kind of, right? I hope that you know, okay? That Boltzmann approximation and all, right? So this formula we get after having the Boltzmann approximation only. Okay? Now, so next step is what, guys? Next step is going to be, in fact, you don't have to write this also. I can remove that. You guys note down now, but I will remove it. I'm not going to write this. What will be the Dheeraj sir way of writing this? ठीक है. धीरज सर क्या करने वाले एग्जाम में? तो धीरज सर क्या करेंगे? He will directly write P naught at 400K. NV, at 300, that is 1 into 10 raised to power 19. You can just have a look. NV is given this much. So 1 into 10 raised to power 1, you can forget 1, right? Then, NV actually varies with respect to temperature. NV varies like this, T to the power 3 by 2. Okay. How Dheeraj sir know that? So you should know that your NV formula is nothing but 2 times 2 pi, okay, NMP, that is effective mass for the hole, times KT by H square to the power 3 by 2. So this is a 1 inch long formula, but only focus here is what? NV, how NV varies with respect to temperature, right? That is this. So, temperature at 400 upon temperature at 300, right? I mean, the NB at 400, you have to evaluate, and it is given, right? So this is 3 by 2. So you have to just multiply, right? So this is nothing but NV at 400. This is nothing but NV at 400, okay? This is NV at 300, and this is the multiplier that you have to multiply, 400 by 300. This is how Dheeraj sir is going to do in the exam. And then what he is going to do, e raised to power minus your gap, EF minus EV, this gap. EF minus EV. This gap is given in the question already. What is that? That is 0.35 electron volt is given. Already it is written. Fermi level is 0.35 electron volt above the valence band energy. So this is okay. 35 upon 0.026 KT is also there. KT at 300 is given, but it will be nothing but multiplied with 400 by 300. Why? Because kT is directly proportional to T. Your thermal energy is directly proportional to T. So what are the changes we have done? If you are trying to find the whole concentration at 400 K, you have to multiply this with NV, okay? And you have to multiply this with KT. That's it. Okay. I hope this makes sense, right? So I'm just going to remove this again because it is making little, kind of cluttered here. So I'm just going to remove it. And now you can just solve it. Okay. So now what is your job is to be done, right? So this has to be cancelled. These two zero has to be cancelled. Now you should know how to use calculator. You should know how to use calculator. This is where everyone makes mistake. अब देखो ज्यादा टाइम नहीं लगने वाला है बट स्टिल दिस क्वेश्चन इज नॉट एट ऑल डिफिकल्ट. That is our perception that this question is difficult, but many students, when they come out from the examination hall, in fact including me also, when I come out from the examination hall, I always claim that this question was difficult, but this was not difficult. What is the difficulty that we are experiencing? We are not smart. See, in one line we can get the answer, right? But now how to handle this guy? One of the biggest, okay, situation is there, right? So P naught at 400K. See, this guy, this 10 raised to power 19 has to be handled separately, guys. Please remember that. Please don't touch it, okay? Don't touch 10 raised to power 19, okay? Please keep it aside. Now, what is there? You have to use online calculator for 4 by 3, 3 by 2, e raised to power minus 0.35. Now, electron volt in the numerator, electron volt in the denominator. Forget that also. 0.026 into 4 by 3. So this multiplier is there, right? Now I'm just going to solve this using online calculator. Using online calculator. Don't break your head by yourself, okay? And then adjust this manually. Okay, or I will show you, okay, how to adjust, okay, manually. Now let me use the online calculator because everybody is going to fail here. If somebody is not comfortable using calculator, online calculator, right? Earlier we had, scientific calculator, so everything was available, right? Just we have to press at the end the engineering button, and we used to get the answer, right? And I used to solve devices question. In fact, my brother was there, right? One of my cousin brother, right? Uh, you know, using online calculator, फटाफट आंसर, ठीक है? I have seen, but now let us solve using online calculator. How can we do this? तो आपको करना क्या? Let me explain first because I can't show you, the numbers over there. So first of all, you have to press 4 by 3. Follow these steps in online calculator. 4 by 3, then multiply with 0.026, then take the inverse, or you can say take the reciprocal, multiply with 0.35, and then press the red button. That will give you negative sign. Then take the exponential. Then always press equal button, guys. Always press equal button because you know that online calculator has one disadvantage. It does not have anything to store. Okay, आपको प्रेस बटन करना ही पड़ेगा, प्रेस करते रहो. Otherwise it will again it will start from the scratch. Then what you have to do? Then then press multiplied button, then take the parentheses bracket, 4 by 3 you put, then take what? X to the power by, so that you can put this 1.5. 3 by 2 means 1.5, and then press equal button. You will get the value, final value. And then what you have to do? According to the question, you see they are asking answer into 10 raised to power 13, means from this, okay, out of 19 you have to only separate 10 raised to power 13, means 60 you have to multiply. So you have to shift the decimal, to the left. Okay, understand, that is very important. So you can just multiply that, right? So you will get something around 63.48. Okay, Okay, and the answer key was given from 60 to 70. So I'm just going to show you. Okay, let's have a look. So online calculators. It's time to demonstrate you using online calculator. Okay, I'm just going to solve it. Yeah. So, yep. So I'm just going to start solving from the beginning. So the very first thing that we have to do is 4 by 3. Then multiply with 0.026. ठीक है, ये काम कर लिए. Then press the 1 by x, like it will give you the inverse. Again press equal sign. Many times if you press equal sign does not matter, but you have to press equal sign equal sign. ये बहुत बड़ा error होता है, right? And then what you have to do here is multiply with the 0.35. Okay, that was given as EF minus EB. Then press this red button to have the negative sign. ठीक है? Okay, then take the exponential of that. ठीक है, ये take the exponential of that, so you got this much. Then multiply with, take the parentheses. Okay, that is 4 by 3. Okay, close the parentheses and take the power. How can you take power, anything to the power, that is x to the power by, and there is 3 by 2 means 1.5 you can say. Okay, now press equal button. You got equal button, right? Press many times. That is, but this is not the answer, since you have to adjust. So what you can do here is you can multiply 10 to the power, again power, right? 6, because 10 to the power 19 is there, you take 10 to the power 6 out, because 10 to the power 13 has to be separated. Okay, so you see, this is the answer. You don't have to do manually also, right? So your answer is going to be what? Your answer is going to be, I hope how to use calculator is clear. Okay, this is where I used to make mistake, everyone does mistake. Now confidently you can say, yes sir, my answer is correct. Okay, so this is where everybody makes mistakes. So I got the answer as 40 uh, 68 point, so P naught at 400 K 63.48 into 10 raised to power 13, right? So this is the answer that you have to put, and the range that was given in the exam was 60 to 70. तो आपको इसमें 2 marks मिल जाएगा. ठीक है, I hope you might have enjoyed the session. Solution, in fact, we will meet in another solution. ठीक है, तो मेरा काम क्या रहता है कि I always try to simplify everyone's life. एंड आपको एग्जामिनेशन में ऐसा मत सोचो कि आपको फॉर्मूला आता है एंड ठीक है, देयर आर सम सब्जेक्ट लाइक डिवाइसेस में पर्टिकुलर, अदर सब्जेक्ट्स की बात हम नहीं कर रहे हैं, डिवाइसेस की बात कर रहे हैं कि जहां पर आपको कैलकुलेटर यूज करना पड़ेगा. समटाइम्स यू नीड टू यूज कैलकुलेटर, राइट, जहां पर इस तरह का वैल्यूज आता है. ठीक है, other subjects you can ignore calculator also because simple values, but sometimes you have to use calculator too, because under the pressure you might commit mistake, right? So my suggestion is try to practice, and you have to start from the back. It is just like climbing up in the tree from just making our head down and climbing backward. Okay, life is like this. Okay, so there is no straight path to success, understand? And this is where people who are from village, right, people who are not having laptop, in fact I had no laptop, people who are practicing on mobile phone, सो उनको उनकी रैंक नहीं आती है. केवल एक ही रीज़न रहता है, मेरे पास भी नहीं था पहले, है ना, तो आई आल्सो स्ट्रगल्ड अ लॉट. ओके, सो इसीलिए मैं बोलता हूँ कि आप अपने दोस्त का लैपटॉप यूज़ कर लो, कैफ़े में जाके प्रैक्टिस करो, अगर आप गेट की तैयारी कर रहे हो, इफ़ योर नो सो तभी आपकी अच्छी रैंक आएगी, बाकी रैंक नहीं आ पाती है. ठीक है, लोग कहते हैं यार कि आपने कोचिंग किया, आप यहाँ से कोचिंग किए, वहाँ से कोचिंग किए, आप इनसे पढ़े उनसे पढ़े, राइट, और टीचर भी कुछ भी बोलते रहते हैं, राइट, कि हाँ. ओके, सो रिमेंबर दैट, जो भी बोलते हैं ना कि मैं ये सब्जेक्ट बहुत अच्छा पढ़ाता हूँ, ऐसा वैसा, देखो पढ़ाने के बाद बच्चा इम्प्लीमेंट कर पाता है कि नहीं गेट एग्जाम में, दैट मैटर्स अ लॉट, क्योंकि उसको अगर एग्जाम में वो नहीं कर पाता तो कोई मतलब ही नहीं है, ठीक है। अगर वही टीचर एग्जाम देगा तो उसको भी डिफिकल्टी आने वाली है। पढ़ाना बहुत सिंपल है, राइट? मतलब आप बता सकते हो चीजें अच्छे से, बट एग्जाम में सॉल्व करना एज एन स्टूडेंट थोड़ा सा चैलेंज रहता है एट द एज ऑफ 22, 23, 24। सो आपको थोड़ा सा, you have to practice hard, using online calculator. Okay, so we'll take more problems like this, and we'll thank you. Keep learning.